Dude, Claude is so slow right now. What the hell? Alright, there we go. Alright, let me just finish setting up everything. Alright, seems like we're good to go. Alright. Let me make sure the volume is okay. Seems okay. Alright. I guess we can start the next part. So let's see. So we did branch last time. the J instructions. And the loads and stores. So let's see. I guess now we're doing the next part. Let's see. So after these will probably be AUIPC, AUIPC, yeah. It's AUIPC, and let me just copy this order real quick. You know what, I'm gonna copy actually all of this. Just these two for now. And I'm gonna put them here. Alright, now we need to, let's see what's here. So let me take a look at the spec real quick. AUIPC, 32-bit offset. Yeah, filling the lowest bits with zeros, add this offset to the address of the UIPC instruction. Alright, yeah. I guess it'll just be ALU result equals the PC value plus the install immediate. Should be that. Same with LUI. So instead of here, it's just gonna be alien result and no write register. Alright, let's check these two cases. Right. Well, we're not actually done yet. We still have to Dude, I can't type right now. The M extension and the F extension. Right. Alright, next part. Alright, so the next part will be up here. Let's just grab the next instructions, which will be all these ones. We'll just do all the M instructions right now. Alright. Up until remainder unsigned. And yeah. Should be good. Okay, let's see. Alright, so multiply or writing to register. Let's see. This one should be pretty simple. Daily result just be equal to the value of each. So this multiplied by rs2 value, and that should be good. Now here's where it's a bit different. Oops, where'd I go? Here's where it's a bit different though. So we have, alright, so we have, because this can be assigned values, so we need, interesting. Okay, I guess we can just replace this with that and replace this also with that. And we're gonna write this. And this one also needs to be here. Alright, that's perfect. And here we can write LU result. I have a feeling we need to do something here with this, but I'm not exactly sure. Let's check. Oh, okay, those are correct actually, never mind, okay. I just didn't know if you need to store this in a struct, but I guess it's fine to just initialize it here as itself. We just have to change the values, basically. So it's like this. Oh. Same. Here. And this will just be rs2. This won't be a pretty long stream today. This won't be a long stream today. I just want to get a couple done. Alright, because I'm pretty tired, low-key. But I just haven't streamed in a couple days because of like projects for school. And you can't really do anything about that, so it's all good. Same here, rs2 value, upper is changed. We have this. Now where it's a bit different. I guess we can still hold these values here, the dividend divisor and all that stuff. Except we just have to change this part here. Same here. Alright, so rs2. rs1, rs2. And yeah, the result can be the same. Or actually no, we need to call it ALU result. So ALU result. And we'll change that wherever it is, so. And we're not writing the register anyways, so it's okay. Alright, so yeah. I think that's good. We will move on. Let me just copy this back. Alright. this. And we got this. Now LU result will be equal to that. Yeah, that's good. And yeah, that's perfect. Next one. Rs2 value and get alien result, and we'll copy that in wherever necessary. And we do not need the right reg. All right, that's good. What's going on here though? Divisor, Rs2, oh yeah, extra parenthesis. All right, okay. That's good. Okay, yeah, that seems to be good. Everything's good there. This one though. Let me just replace. I'll just replace all of it. Alright, that's good there. Same with this. But this will be Rs2. And our LU result will be that. Okay. And we don't need to write to the register. So we are good there. Okay, that's all the instructions there done for that. I'm gonna do a quick check with Claude, make sure everything's good. I think everything's good though on my end. Just wanna get a double check. Let's see. Nope, there seems to be an issue. Declaring local ALU result variables inside the cases, shadowing the outer ALU result like it's written. Let me see. All H, all HU. Calculate upper. All right. LU result here. Since that's what we said as a variable. And what's the problem here? Don't redeclare LU result inside cases. Just assign to the existing one. Oh, okay. No, that's such a that's such a dumb problem. I can't initialize them with the value since they're already initialized. They'll rewrite the value. I totally forgot. Okay, that's the only problem that's not a bad problem. So we don't even need that there. I think that's good. Because I was copying and pasting, right? So I totally forgot that I don't even need that. It's good. That seems to be good. And I think everything's good here. All LU result and all LU results are still good. I think. Yeah, I totally forgot. Alright, now we can check. Now we should have a perfect case here. Alright, that was pretty simple. Let's just move on to the next one. Alright, so that case is done. Now we need to move on to the next cases, which will be those other instructions. Floating point. Hopefully I don't have to change too much for those. I'd like to be done with this function today. Oh, we're probably not going to. Probably not going to. We'll see though. Let's rewrite. We'll go slowly through them and just slowly rewrite them. Alright, that's interesting. So it's kind of the same as... It's kind of the same, right? So... I'm gonna take a reference up here real quick. We just did the RS1 plus immediate, right? So let's see what we need to do here. So it is RS1 plus immediate here as well, but alright, let's just start. Alright, so this one's gonna be a different RS1 though. It's gonna be the floating point one, I believe. Let's just go check though. Okay, I have to check in here for the actual thing. Float load word, and oh, it's actually to a. It's from an RS1 value. So the RS1 register is X. It's gonna be integer. But the floating point register is what we're actually putting it into, which doesn't really matter now. Okay, yeah. I think it'll just be that then. Literally just be that. And we call this failure result. And it would literally just be the same exact thing here. Or wait, no. No, it would be, because we're just calculating the offset. Let me just go back a second. Yeah, it would be the same. So, yeah, we can check these two cases. I forgot. We gotta make sure to check that. Alright, now the next case is... Alright, let's see. F add S. Alright, so we have a floating point register. Alright, so now we actually need floating point values, so our failure result is going to be I believe it's, let me check in the struct to make sure, but I believe it's rs1f value or something. Let me just check though in the struct. Yeah, rs1f value. So we initialize the rs1 value as the integers and then the rsf values as the floats. Okay, yeah, that's good. So we have rs1 value plus, I'll just copy from here now since it's easier, and then rs2f value. And yeah, that's good. We do the same with the rest. This will just be multiplying. This will be subtracting. And this will be dividing. We don't need any checks because floating point standard already covers everything, so that's good. Floating point square root. let's see, floating points are root now. So reading from the floating point register. So automatically we know that we need it to be that value. Or I guess we can just, I think it'd be easier to just do this. We can do that. And instead here we can, wait, well, let me see the value again. Was it freg? Yeah, it was an freg, so we're fine with that, okay. So like that, and then we can, instead of writing, we can just declare LU result here and set that equal to the value here. That'll be pretty simple. And yeah, that's good. Next, same here, we're just gonna call it value 1 and call it value 2. It just changes this to rs2. And calculating the minimum of the two values, so in LU result will be storing stdef min of those two values, which is good. Not writing to anything. And it's the same case for these two, just using fmax instead. So float value, rs1, rs2, it'll result fmax of those two values, and then we can get rid of this. Okay. Let's just do a couple of these checks right now, just to make sure we're all good. Okay, yes. Alright, let's make sure I didn't declare anything improperly. Yeah, let's check. That was an oversight as well. Do I have the LUF result? Yeah, I do. Okay. I remember. Alright, that's interesting. Okay. LUFR results. I totally forgot. We'll just copy that in. Like literally everywhere. Yeah, they're all good now. The float ones as well, right? I believe the float ones should also be. Yeah, the ALU one, the load ones and store ones should also be the same. Or actually, no, I guess not, because the value itself, though. Yeah, the offset's always immediate of an integer, so as we see here and here, the offset going into the integer register. Damn, I'm pretty tired today, dude, but we can keep going. We just gotta continue. Shouldn't be too bad. Just to do a couple more at least before we end the stream. All of these are also ALUF results. Okay. Is there another problem too? Alright, let's do the big check here. And that's what we figured out here. Okay. Alright, remaining instructions. How many do we have? Actually, not a lot, to be honest. I think we're doing good. Dude, holy. Alright, okay. We can just store them each as a value. I can tell I'm pretty low energy today, not gonna lie. Didn't get the best of sleep. It's been kind of crazy lately, but hey, we still gotta build. I missed like 3 days already, so I wanna at least get this part done. We can store an ALU result, that value. Yeah, this value. I'll leave that. Break out. Same here. Grab all these values, replace them. And it would just be a negative R3 instead. We have the same function. Yeah, negative R3 instead. Alright, we're good. But I guess it's gonna be in a floating point register, I believe. Let's check. What is it? The FM? FM's first? FM, yeah. Let me check those real quick. Yeah, they're a floating point register, so they have to be to the ALUF result. Both of these. Let's also rewrite these. Let's see. Replace these with these. And it will be the ALUF result. But we have a negative RS1 and a positive RS3. Alright, and this one too. Negative R3 and negative RS1, and I think we're good. Alright, those are done. Let's do the converts. Alright, converts. Alright, let's tackle this slowly through. So, getting a float first, static casting that to an integer. So I guess we can keep that the same, but we want to change this to be RS1 floating point value. Integer value is fine. Static casting the value of that F, but we want to call this alien result. And we're just writing to a regular register, so that's fine. Integer register. I think, yeah, that's how we tackle those. We just slowly implement. But here, it would be LUF results. And yeah, that would be good. But this would be rs1 value, just a regular rs1 value. We're reading, now okay, here, same thing here. We're reading that floating point value first, then storing that into a regular ALU result. Oh wait, we don't want to make the same problems as here. Not initializing them. I don't want to hear Claude say that again, so... Alright. Alright, that's good. Same thing here. Reading the arson value, static casting that into the float, and we'll call this LUF result. Alright, we're almost done. Almost done with these. A couple more to rewrite. Alright, interesting. Alright, let's go through this slowly. Alright, so rs1, rs2, we got the bits 1, bits 2. Alright, so we're reinterpret casting the rs1 value into the bits to be an unsigned integer, from float to unsigned integer without changing any of the memory. So all the bits are in place. We're masking it and then ORing it with the next set of bits. And then setting that result into a float value, back into the float value, without changing the bits. Alright, let's rewrite. So this, first of all, these two can take this value. Bits can stay the same. Should we... Well, that's kind of like a memory thing, so should we save that part, or... Should that be ALU result, is what I'm thinking. I'm not exactly sure, though. Like, we call this ALUF result. And do that like this. Not exactly sure, but we'll take a quick check. We'll check right now. Okay, yeah, let's check. First, I want to check all the other ones first. Before Claude gives us the answer, I just want to check myself to see if I can come up with an answer on my own real quick. Okay, I'm looking for one of these ones, right? Alright, grabbing the 31st bit from rs2 and the bits 0 to 30 from rs1. I mean, I guess we do have to calculate that right now. Not exactly sure. I think... I don't know, maybe Claude might tell me to re-put this later. Let's see what he says. Not a memory operation, it's pure bit manipulation. Yeah, okay, yeah. I forgot. We don't need to initialize this. But I keep making that same mistake. Any other mistakes here? Yeah, I know. Remove the type declaration. Let me see. Let me see if it's the same. rs1, bits 1, bits 2. He also did the memcpy. I mean, I think I did it right. Masking. Yeah. Yeah, it's all right. Okay. Yeah. All right. All of them are right. We can rewrite these two as well. It's essentially the same, so just grabbing these, changing those values. Bits are the same. And we want this to be ALUF result. Alright. Seems to be good. We don't need to write to the register right now. Yeah, it's all good. Alright, same case here. Okay, with that. XORing these two bits, doing a mask to get the 31st bit. Alright, yeah. Okay. Everything seems to be good with these three. Okay, get rid of that. Alright. Next, we have the move instructions. Alright, so for these ones, taking rs1 value from a floating point register, so we can replace that. We have the raw bits for unsigned integer, and we're putting the value of rs1, the raw bits, into raw bits for unsigned integer, so float to unsigned integer, reinterpret casting, and yeah. But let's see, we don't want it to be bits. We can just call it, we can just do ALU results. It should be the integer one, so it's just ALU result. And we don't need the right register. Alright, same case here. This is just the opposite way. We're going from integer to float in bits, so that's fine. We don't need this. We're just gonna make this ALUF result instead. Okay, that's good. Next. Alright, now we have the comparison, the floating point comparison instructions. Let's see, so they're taking two register values and doing a Boolean operation on them. So essentially it'll just be the same. Oh, I forgot to change this. I forgot to change this. 1 second. It should be rs1 integer value. And let me make sure I just didn't mess up anything. Okay, that's good. Alright, now we need to take alright, so rs2 here. We're doing a Boolean operation on these two and then writing it to a register. We don't need to write it yet, so wait, okay. How exactly are we gonna do this? Okay, so we're getting it as true or false, but we do want the ALU results, so let me bring this back for a second. Oops. Went back too far. Okay, wait, so we have Okay, I guess, yeah, we can just, alias result it. And let's just call it, like, static cast. On the EQ itself before we even write it. So good. And I think that should be a-okay. I'm gonna do the same with these two as well. So we're gonna do that. I'm gonna do that. And call it like that. Same with these last two. This last one. And we will replace this with the alias results. Static casting them all into an integer. We can double check though. In the spec, feq.s, they all do store into an integer register, so that's correct. Alright, last one. We'll tackle this after. Let's just check. Let's do a quick check though. Where did we last check up to? I believe it was the converts. Or no, it was up here. So yeah, let's do a check now. Check on all of these before we do the last one. Let's do a quick check. Alright, all good. F class. For F class, yeah, okay, I'll do that. Alright, let's see. Generally should be the same logic. Just have to change this to be a floating point. Get the raw bits, and we are, okay. What are we actually storing to the register? We're writing mask to the register, so we don't need the mask anymore. Instead, we want to change all of these values to be the alias result itself. Wait. Yeah, it's just a regular integer value, I believe. Let me just go back. Yeah, it was on its integer value. Yeah, so we want it to be hey, what's up, Ben Paulo? I'm just rewriting my risc-v CPU interpreter right now to be able to use pipelining. This is for a CPU emulator project I'm doing. Alright, we want all these values to be alias result instead of mask. So we can just place them for each place. Anything else we need to change here? Well, we don't need to write to the register anymore. I think that's good. The bits casting. Alright, let's show him my change thing. Alright, let's show him. Okay. Yeah. That's correct. We do have the final two. The final two being, well, actually the final three, but the last one's kind of just like an unknown value. These two. These two should be, it's the same. We're not writing to register anything, so like, it's not really anything special. It's literally, yeah, we just keep this the same. We don't have to rewrite this part, I don't believe. But yeah, we do have to write the next part. Let me just check these. Yeah. We want to flush them or just stop immediately. For simplicity, stop immediately is fine for now. Yeah, we can just stop for now. We don't have to flush them. Okay, yeah, we do need to write this is the switch case, so alright, yeah. So at the end of the switch, we'll have the next value, so let's see what we actually need to do. I need to take a reference though. I need to take a reference from up here. I'm gonna delete it after, but I need to just see for a second. Okay. You know what, I'll just grab these values, I believe, for now. I'll just grab these. I just want as a reference. I need them down here as a reference to see. Real quick. We'll just put them here for now. Alright, so what do we need for the next one? So that's fine. But it's gonna be not IDX, it'll be X to mem. It'll be X mem register. PC should be the same, but just X mem instead. But it would be like the current one, so this one would need to be IDX. We wouldn't need any of these though. Well, I guess we would need rs2 and rs2f values because they are used in the next stage. But we can get rid of these though, the rs1 and the rs1 here. We can keep those. So XMM for these two. And it's gonna be the or wait, hold up. It would be, what is it on our struct again? Right. Just rs2 value, and then rs2f value. And this would be x underscore mem for the bubble. Wonder what's wrong here though, wait. Let's add it in here, I totally forgot. And it'll be a float value. I need to see for a second, one second. I think I'm getting something confused. I feel like I was getting something confused, but I guess if I can't find it, I'll query Claude about that. I think I'll check it here actually. I think it's in my decoder. Well, let me just save these values. Okay, where is it? I know something is further defined. Where's 2? I believe that's good. What else do we need? The ALU results that we got in this round here. And that's just going to be the ALU results variable that we got this round. And same with the floating point ALU result, we need the floating point one too. So yeah, I think that's good. I'm just gonna ask Claude though, like if we actually need, I'm just gonna check though. I think we're all good. I think we're all good here. I'm gonna check the whole function actually. The whole function itself. And we'll make sure everything's good. Before we move on, just to clarify, do we need the... I just want to clarify this. I kind of forgot if we need that part or not. Yo, what's up, XO? Welcome back, bro. Yeah, I've seen the Project Rebirth. What is that going to be about? You need it for the FSW? Oh, wait, let me check. FSW? Let's check. Oh, you're right. Yeah, FSW does take a floating point. It does put it into the floating point register for ours too. Yeah, okay. We're good. Code looks correct. One small thing for e-break call. See all that equals true with it. Still fall through. Oh, okay, I see what you mean. Instead of break, just return early, so we don't even hit that block at the bottom. Yeah, that would be pretty wise to do that instead of break. Yeah. Okay, that's pretty good. Alright, we're done with these instructions right now. But okay. Yeah, everything looks good. We need to start with the next function. I guess I'll just do a little bit of it since we actually finished this part pretty early. Alright, so the next part. Okay, I didn't mean to go all the way up there. Alright, yeah. I think we can start the next part now, which will be the memory stage. Project Rebirth is going to be all the scrap games into one, and I'm not talking about gameplay, I'm talking about visual-wise, and the real gameplay is going to be RNG Tycoon. It's another project that's going to be named Cartoon World. Hey, focus on the main project first. Set cartoon world aside. Focus on the main project. Focus on the main game. For the Project Rebirth. You already know your mistakes from the past. Tackling too many things at once. Get every main thing done first, and then do designs. You can do designs alongside with it, but just don't neglect the main part, of course. Right, memory stage. Let's set a forward declaration to this in here. Okay. Alright, so let me try and recall what the memory stage was about. I believe it's just for those certain instructions like the save and load instructions, we need to actually put their values in and actually grab them from memory using the ALU result that we calculated before. I believe that's what we have to do. Let me just do a quick check though with my notes. Yeah, memory access. Read from a write to data memory. Yes, for the load and store instructions. Takes the address calculated, so the ALU result. We need to actually retrieve the data. It takes the value from register and push out to RAM, the address. Okay, yeah, I think I got it. I remember now. I guess we can start by doing this again, of course. We want to grab these as well. Well, we don't need to initialize, we already have them for last time. Yeah, I guess we can just do the bubble first. Alright, so how are we gonna do this memory part? I guess we can do we could do a switch case. We could do a switch case statement here for each of those instructions as well. I think we can start with that. Let me just go back up here real quick and check something. No, that's too far up. I will eventually get rid of this part. Where are we? You could make the two games together, but I highly suggest you do one first. Whichever you're more interested in, do that one first. You can add the second one after. Okay, yeah. We can initialize, we can set that value again. I believe so. What was it at the end here? Let me go back up for a second. Okay, I think I got it. Inst. And I think we're good to go. Let me just ask about my idea to see if it's a good idea. So my plan is to use a switch case statement on each of the load/store instructions and assign the memory as planned. If he says it's a good idea, then I'll go ahead and implement it. Right, switch from bubble check. Oh, yeah. It's gonna be, yeah. It's gonna be xmem. What else? Yeah, this one too. It'll be mem right back, I believe. From WB, right? Yeah, okay. Your plan for switch is correct. Alright, yeah, so our plan for switch is good. Then let's go ahead and tackle that now. Call it, we'll do inside name. And we're gonna tackle each of the different instructions. So I guess we can start with, let's start with the load. So case, let me go to the spec real quick. Alright, case load. Yeah, we can start. So for the case load byte, oops, I forgot the other one. Okay, there. Alright, okay. Now we need to implement the memory. So let me go back up here and grab some of these. Oh, where is it? Right here. Alright, so I'm low-key gonna grab some of these. I'm just gonna grab some of these so I can have them as a reference. We'll grab these ones first. And let's just do the same one here. I can't type right now. Alright, insert name. Alright, I'm just gonna put these here for now. I'm gonna delete them after. Alright, so we need to actually implement the memory now, so... Alright. So our ALU result value from before. So that would be our x.mem reg.alu result is what we're going to be using. And I just want to take a look at the struct here for a second. In here, the mem right back phase. So we do have a mem read ALU result. Let's see, so I guess we would store it in ALU result here. Mem read would only be for okay, that's interesting. Okay, yeah, I guess we can sign that, so the alien result itself. I should probably initialize it up here. Where am I at? Right here. Alright, so let's actually initialize that. Just like we did up here. I wanna see how I initialize that real quick. Yeah, just like this. You need to grab it's just gonna be alien result though 1. Initialize it up here. So now the current alien result will be changed. Okay. And I guess we could. I think we call the read byte, but I'm not exactly sure about that. So we have xmemreg, and we have alien result from that value. So that's essentially just this value that we got here. I need to take a look real quick. Hold up. It might give me some insights to something if I take a look up here earlier in earlier iterations. Okay, yeah, no, I understand. Yeah, okay, I was right. I was just overthinking it. So yeah, we also need to read byte here. We do want that value to be read. And we do want to change that value. So let's just say like if that alien result is 0x80, so like it's essentially the same as this pretty much. Alien result or 0xff. I'm just gonna copy this. I don't want to. All right, yeah. What am I doing, dude? I'm messing shit up. All right, yeah. And we don't need to write, so we just have the alien result as that value. And I think let's see if that's a good implementation or not. Start logically correct. Arrive that block at the end. You'll need to decide. Wait, wait, so he's reading? Okay. Should get the memory values. The original alien result. Okay. would need like a little bit of elaboration on that. Wait, let me see if I can think why. Wait. You need to decide which alien result to pass forward. You're declaring a local alien result. Here that will override the alien result from. The loaded value is what needs to be written to the register and write back, not the alien result. I see. Okay. Yeah, we could use our memory instead then, instead of having it be our. So let's initialize memory instead. In our struct, it was unsigned sure memoried. Yes, it was. Okay. Yeah, that makes sense actually. And I believe that's the same thing here. Passing that value, okay. Yeah, I think, yeah, I got it. I mean, I think that's a good stopping point for today, to be honest. We can continue on tomorrow. Seems like we have a pretty good workflow. And yeah, I'll see you guys tomorrow.